Right, Dave again here with another question from the question bank in the style of what you find in your Hayes and Harris Math SL textbook in Chapter 6C. In this question, we're given a quadratic, and part of it is shown in this graph. Part A asks us to find the x-intercepts of the graph. So if we're looking for x-intercepts, we'll find them by letting y be equal to 0. So we have our function y equals 8x take 2x squared, and we'll let that be equal to 0. Now to solve this for x, you might be tempted to divide both sides by x. But you have to be careful because anytime you divide by your variable, you're eliminating 0 as a solution because you can't divide by 0. So instead of dividing by x, what I'm going to do is I'm going to factor out an x. In fact, I'm going to factor out a 2x. 2x away from 8x leaves 4. 2x away from negative 2x squared leaves negative x. Now what I can use is null factor law, which tells me that 2x has to equal 0, and or 4 take x has to equal 0. That means that x equals 0 and or x equals 4. If I had divided by x, I wouldn't see this as a solution. Now from the graph, it's pretty clear that it is a solution, so I might have figured it out anyway. But now I know the x-intercepts. 4 and, not 2, 0. Part B says write down the equation of the axis of symmetry. Well, the axis of symmetry runs straight through the graph, and because the graph is symmetrical around the axis of symmetry, the distance between the axis of symmetry and one x-intercept is the same as the distance between the axis of symmetry and the other x-intercept. This is the midpoint of the two. And the midpoint between 0 and 4 is 2. Which means that the equation of the axis of symmetry is x equals 2. Remember, it asks for the equation, so we need to express it as an equation, and that's x equals 2. Simply writing 2 on the page will get you no credit, unfortunately. Remember, the axis of symmetry is a line, and it's all of the points on the Cartesian plane for which x equals 2. Finally, we want to find the y-coordinate of the vertex. The vertex is up here, and we know that it has an x-coordinate of 2 because it lies on the axis of symmetry, and the axis of symmetry is x equals 2. So the only remaining question is, what's the y component? To solve that, I'll just take my function, y equals 8x take 2x squared, and I'll let x be equal to 2. That's 8 times 2, take 2 times 2 squared. 8 times 2 is 16, and 2 times 2 times 2 is 8. That means y equals 8. So the vertex is 2, 8.